Okay, so before we start working on this again, we'll need to unpack it. So that's RBD unpack, not just the normal unpack, okay? They are different. So RBD unpack, and that will give us access to everything separately. So I just noticed this weird error here. So this happens sometimes. This is from the wood fracture. So these are the pieces which are cutting the wood. So the wood is formed with a bowline fracture, right? And this is the cutting surface. So, you know, sometimes you get errors with us getting stuck in. So, you know, we can go back and try and tweak it, but an easier way is just to delete it like that. Grab this bottom piece and delete that as well. There we go. That should be fine. And let's just double check actually on this side. Yeah, let's see the same name attribute. So if we copy that across, so alt click and drag. So we delete it on both sides there. Okay, if we delete it on one side, then we'll get some weird result there. So, okay, I'd like to just straight away just run a simulation on this. So I'm going to plug in the high-res geometry there, and then the proxy geometry into the right-hand side. And I'm going to leave the constraints, okay, because we'll get an error if we plug in the constraints and don't give ourselves any constraint properties, okay? So I'll just leave them unplugged. I just want to see how the pieces interact with each other, how they fall. So bullet solver with just a ground plane. Let's just give ourselves some kind of camera. If I control click there and then click on this. Okay, maybe get nice and low. Cool, something just like that. Okay, and then turn that off because I will move the camera again after. And then just get rid of these markers. Just click on the cursor, go to full screen, and then let's run a flipbook. See how that looks. So I just stopped it there. I've got what, 40 frames. So yeah, I don't know about you, but I think it looks really cool. Again, I really like, you know, all the separate slats. But now we've got that extra detail of all these cuts in the wood and the fiberglass. I'm not sure what it is, to be honest. And the glass as well. There, you can see it there. That looks really cool. Awesome. So, you know, that's without constraints. So let's give it constraints and see what happens then. Dive back inside here. So RBD constraint properties, we've already got constraints. So we've got constraints between, within each kind of group of materials, but nothing between them all, right? And you may want to do that, you know, well, in some projects you will do that if you want the whole thing to stay together. But the aim of this project, I don't know what's happening there, some weird visualization problem. The aim of this is to kind of just blow this whole building up, you know, from the first shot. So we're not too worried about, you know, that the glass is stuck to the frame and the frame is stuck to the bricks and so forth. You know, it's just instant kind of demolition, right? Let me just double check there's nothing. What's going on here? Let's go. Sometimes, you know, it could be a viewport error. So just go into new pane tab type, view as scene view, spacebar and F, and there we go. Back to normal. And then just delete that one. Put it back over there. Let's put our background back to dark as well. Oops, what have I pressed there? Press D, background, dark. Great. So yeah, let's give ourselves some constraint properties. Connect up the constraints. The pink line through the middle is always constraints. Okay. I'm going to drop, I think the strength I ended up on was 8,000. So another thing I wanted to speak about is that, you know, we're going to be using forces to get that sense of explosion here. And with constraints, excuse me, you know, if you have an outside force just pushing, so like wind or some kind of explosion or velocity, that's not going to break the constraints automatically. The only thing that will break the constraints is a glue constraint is collision. So when these objects collide with each other, and by leaving gaps here, we don't have constraints, like I said, between each piece. That's going to give us collisions, and it's going to cause breaking and start a kind of chain reaction. Once one thing bumps into another thing, that will break them. If everything was constrained together and we didn't do any, we'd have to use a SOP solver on the inside, I think, or use some VEX to tell the constraints to break under a certain amount of force. Then I don't think we'd have any. It would be a much more complicated thing. But if it's not necessary, it's not necessary. Try to make things as easy as you can. So let's see what happens. I'm not sure, actually. I haven't done this without the explosion force. If we try and run a flipbook here, we've lost the panel on the side there. Just click. You can see the arrow there. So you just click on that to open it. See if anything actually happens here. Okay, I've just got the 80 frames there. And by the way, just press escape on your keyboard. So go back to the Houdini window, press escape, and then it will, stop the flipbook, but you won't lose what you've already got. So yeah, you can see, what I was talking about, all those kind of chunks holding together each initial piece. So if you remember when we used those assemble nodes at the beginning, that gave us a name attribute for each piece, and each of those pieces are being fractured down and constrained together, right? So each plank will be fractured and constrained together, but all of the planks, they're not being constrained to each other, okay, just within those fractures, okay? So that's the start of a result. You can see we're starting to get some things breaking. You can see some jagged edges there from the wood. So that is a result of constraints breaking. So that's, either from just the weight of the object on itself or collisions within itself. But, I'm not seeing any major issues now. I don't want to focus too much on trying to make this look perfect. Wait until we get the forces pushing on this, because it will change it completely.